What's up, everybody? Welcome back to another live stream from Scalar Learning. And we are in the midst of another SAT week. We're gearing up for the June 1st SAT. And I am trying to get you guys all ready for the math portion. Let me just do a quick sound check here, and we are good to go. All right, so check it out. Here's what's going down today. Yesterday, we started with the no calculator section of the May international test. Today, we're tackling the calculator section, which I'm really excited about. I got the calculator section up here, and as I mentioned yesterday, if you guys don't know this, there's two tests usually given. There's an international version of the SAT. It's not as though they're different tests or different formats. They're the same, but they're just different versions. And there's an international version, and there is also a regular version for kids in the U.S. And a lot of people have been asking me lately, oh, yo, what's up? Thank you. You're the best. So a lot of people have been asking me to tackle these international, because I hear over and over that they're much harder. And I don't know. I haven't done enough international tests to say. I will say for this test, this just happened to be for the no calculator section. We'll see how today is. But for the no calculator section, I actually thought it was easier than the version that I took in May in the US. But now today we're going to jump into the calculator section. Very well could be more difficult. I just forgot. I'm going to load up my calculator here. So I got the Google calculator ready to go if and when I need it. It's definitely good to have this on standby, and I definitely do need it. So here's the deal. If you're new to my live streams and you haven't seen this before, what I'm doing is what I do. Hey, what's up? Good morning. Good morning. So what I do in these live streams is I'm taking the test live for the first time, which means I haven't prepped it, I haven't reviewed it, I haven't taken it yet. I'm actually doing it live for the first time on camera. The reason why I do, and I'm doing it in a time setting, so I got the timer set to 55 minutes. The reason why I do this is because I want to show you the authentic way of how to actually solve it in real time, not to give you drawn out explanations that aren't practical, but to show you the real way to do it. And I'm doing the math the right way, the way that it should be done, and within the time settings, and I'm giving you explanations. So it's always part of the fun, and every now and then, right, I'm pretty darn good at this stuff, but every now and then I will come across something that will throw me for a loop or whatever, and I have to think on my feet, and that's part of it. So I want you to watch that entire process and take note. And from what I've heard, these have been really effective for people in terms of improving their SAT scores. So without further ado, guys, thank you for joining on a Sunday, on a long weekend, and it's Memorial Day weekend here in the U.S., so everybody's got tomorrow off as well. Without further ado, let's do it. We got the timer set. Excuse me. All right. Ready, set, begin. Okay, the number of acres of useful timberland in 13 countries is boxplot. Which of the following close the median? Boom. You just got to know what how to read a box plot. The median is this little line right there. The median is around 7,000. Done. Next. Robert rented a truck to transport materials he purchased from the hardware store. He was charged an initial fee of $20 plus 0.7 per mile driven. If the truck driven 38 miles, so 38 times, 38. 38 is the M times 0.7, 26.6 plus 20 equals 46.6, right? I just plugged this value in here, right? I created an equation and then plugged it in, and I got 4660. Next. The equation, blah, 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 models the relationship between the number of different pieces of music of a certain pianist. Okay, how many pieces did the pianist practice if the session lasted 30 minutes? X is the minute value. So we want to know, what does Y equal when X equals 30? And guess what? 0.1 times anything just means you move the decimal over, so it's 3. Boom. All right. It looks like D wasn't posted on this. I didn't make this. I got this off Reddit. Okay, next. What is the value satisfies the equation above? Okay, we're solving for A. Boom. Let's distribute. Let's distribute. So we're going to isolate. 3A plus 12 plus 6A equals 3A plus 12 plus 30. Uh-oh. Okay. Right off the bat, as a little helper, I can cancel out these guys and cancel out these guys. Same thing on both sides of the equation. Essentially goes away. Actually, I should have done that off the bat. I didn't even think about that. I didn't see that. And then it's 6a equals 30. Divide both sides by 6. Divide both sides by 6. A equals 5. Done. Excuse me. Next. Rhododendron, whatever. It leaves curl up at temperatures below freezing, and they uncurl and widen as temperature rises. The scatter plot shows the results of a study in which the widths of some leaves of the plants were measured at various times over a certain period. And T degrees. Okay, so the width, so it's temperature and width. Solid segment of the line of best fit. Okay, and the dash segment is between here. Okay, so we got two different lines of best fit that kind of hit this. Based on the dash segment, which of the following is closest to the temperature, all this we could have ignored, is closest to the temperature at which the width is predicted to be 42. Okay, here's 42. Let's make it thinner. Right across there. And it's looking like I'm hitting it right at that point, which is 34. You see that? That's the point that it hits it. Boom. Right in those crosshairs. So it looks like it's 34 degrees. All right, next. I like thickness too. Next. A time when the temperature was 14. Oh, another question. At a time when the temperature was 14, the width of the rhododendron was measured. By approximately how much does the actual differ from the predicted value? Okay, sorry. So we got to go back up 14 degrees. Where is it? Zoom in a little. Oh, okay, so here's 14. Oh, I see. Okay. So let's not do that. So the 14, so here's the predicted, which is 10. And here's the actual, that dot, which looks like about 12. So I'm thinking it's about a difference of 2. And let's see. Oh. By approximately how much is the actual measurement? The actual is 2 millimeters greater. Right? The actual was higher. Yep. Approximately 2 millimeters greater than the predicted value. Predicted value is whatever's on that line of best fit. Okay, 7, based on the solid sign. Oh, another one. All right, which of the following could be the predicted width in millimeters when the temperature is between 0 and 12? All right, 0 and 12. Thickness, 0 and 12. So it's in this zone from here to here. So it could be anywhere from, what is that, 6, maybe 7, up to 10. So somewhere in the 7 to 10 zone is what I'm seeing. Let's see. Right there, 8. This is too low. These are too high. Yeah. All right, done. So we've done 7 questions in about 5 minutes. That's a decent pace. An object with a mass of 1 kilogram weighs approximately, okay, an object with which of the following is closest to 2 pounds? So check this out. We go, I'm set up a proportion, 1 kilogram. It's about, well, actually, I already know it's this. But let's do the proper ratio. It's 1 kilogram to 2.2 pounds equals X kilograms to 2 pounds, right? And then cross multiply, and we get 2 equals 2.2x. Divide both sides by 2.2, and that's how you would do it. But let's do 2 divided by 2.2. Oops. Divided by 2.2 equals, boom, 0.9, and it rounds up to 0.91, and there we go. In the triangle above, A equals 45. What is the value of B? Oops, hold on one second. I don't know who this is. Oh. In the triangle above, A equals 45. What is the value of B? Excuse me. 45. Okay, so watch this. We'll set up an equation. 2b plus 31 plus 45 equals 180. That's all triangles. The angles add up to 180, and that's our guiding post. Then this becomes 76 equals 180. And then subtract 76, and we get 2b equals 104. Divide both sides by 2, and I get 52. All right? If you're not as fast with mental math, check your work. Use the calculator, plug it in. But I'm pretty confident with mine, so I skip that step a lot. At a large high school, 300 students were selected at random We're asking a survey. Okay. 300 were selected at random. All 300 students completed the survey. It was estimated that 38%, I'm losing, what's happening here? 38% of the students were in support of a menu change with a margin error of 5.5. Okay, got it. The percent of the students at the school supported menu change is 38%. No, that's too definite and whatever. We can't say that. Maybe. The percent of students at the school supported menu change could be greater, not necessarily, could be less. The margin of error swings both ways, right? If we get 38 with a margin of error of 5.5, it means it could go as high as 43.5, where we add the margin of error, and go as low as 32.5. Okay, that's the swing. It's 5.5% in either direction, so really it's a zone of 11. Okay, between right here. That's it. See that? And then plausible values for this, nah, that just doesn't even make any sense. X minus 3y, blah, blah, blah. Okay, solution. Let's do a little substitution. First of all, I can divide both sides by 3, and I know that y equals 3. Plug that in here. And then we get x minus 3 times 3 equals 7. X minus 9 equals 7. Add 9. X equals 16. Boom. Done. Next. Naya burns 5 kilocalories per minute running on a treadmill and 10 kilocalories per minute pedaling. 5 running and 10, pedaling. So the following equations represents total number of kilocalories Naya has burned after running 50 minutes. Running for 50 minutes. Hold on. Times 5. And pedaling on the stationary bike for m minutes. 10m. All right, there it is. So the kilocalories are 50 times 5. Because, for running, because it says she burns 5 kilocalories per minute when she runs, which is funny because you almost always burn more calories when you run than bike, but it's all good. And then so it's 50 minutes times 5, and then 10 per minute on the stationary bike, so 10m, and then it just becomes 250 plus 10m, which is that last one, even though the order's flipped, but it doesn't matter, right? Think about it. 10 plus 5 is 15, 5 plus 10 is 15. That's called the commutative property. It makes no difference. Just make sure I didn't make any mistakes. I think it's good. All right. Next question. Boom. For the function, what is f of 9 minus f of 1? Plug 9 in right there. So it's 9 plus 7 over 4. That's f of 9 minus f of 1. 1 plus 7 over 4. See, all I did was, you just got no function notation. This means I'm plugging 9 in for x, right? It's replacing the x, so I plug it in, replacing it with 1. All right, 9 plus 7 is 16 over 4 minus, that's 8 over 4. And this is, of course, 4. This is, of course, 2. So the answer is 2. Done. There were approximately blank jobs, and the Bureau of Labor projects this number will increase by 29%. Of the following, which is closest number of occupational project. Okay, so an increase of 29%. The fast way that I like to do this is I don't just multiply by 29% add, I multiply by 1.29. That will give me the new value with a 29% increase, okay? 0.29 represents 29%. So 1.29 times, hold on, 113,000 equals 145, 770, 145, 8. They rounded up to the nearest 100. Boom, done. Next, survey was conducted using sample random California State Universities. Press the survey were asked to name the publishers of the current test. Oh, sorry, I got to reread this. A survey was conducted using a sample of history professors selected at random from the California State Universities. All right, if they're saying what is the largest population, these questions have to do with the fact, like, where's the random sample drawn from? Since it's drawn from California State Universities, I would say it applies to all history professors. No, that's way too broad. Way too broad. I would say this. All professors at Not, I can't say California because they only did it from history. So if it's just not right to extend it beyond that. But it's the reason why we can extend it to all state universities because the random sample is from that pocket of state universities. So if it's truly a random sample, it should be representative of history professor at California State University. Company produces board games and sells them online and in stores. The quadratic function models the company's monthly profits, blah, blah, blah. How many board games must the company produce and sell in order to earn the maximum? So the maximum is occurring right here at 1,400. And we don't actually have the graph, but look, here's the thing. This is a perfectly symmetric parabola. That's how they are. That's how they generally roll. And we know that we can look at these x-intercepts and we know that the vertex is occurring right in the middle of them, in that midpoint. So all I got to do to find that midpoint is add these and divide by 2. So we're finding that exact middle value. Or you could just kind of plot it on a number line and figure it out. This is faster. So 70, so it's 80 over 2, which is 40. Oh, and it's in thousands. So there you go. Done. A number n is increased by 6%. What did I say about increases? It's like you just multiply by 1.06. N is increased by 6% and it equals 318. What's the value of n? Look, I just made a nice equation just by kind of processing that. Now, so 6% increase of n equals that. Well, to isolate, we just divide, get rid of the 1.06, right? Just standard variable isolation. 318. Oh, shoot. 318 divided by 300. Boom, done. And all right, I think we're about, not yet, almost at the halfway point. All right, here we go. The equation above can be used to calculate the distance in miles, blah, blah, blah. Okay, for any positive constant k, all right, I should probably read this actually. Travel by a car moving at a speed of 50. Right. For any positive constant k, the distance the car would have traveled after 9k hours is how many times the distance the car would have traveled 3k hours. All right. It's triple. Am I missing something? It's just 3. But let's plug it in, I guess. It's so weird. 9k would be our t value. So they want to know how many times the distance it would have been this versus if we plug in 3k and multiply it by 55. So 55, I mean, this is a waste of time. I think I know it's 3, but 55 times 9 equals 495k. And this is 165k. And this is clearly 3 times that. So I think, unless I'm missing something, I believe that is the answer. I think they're just trying to, I don't know. All right, next, in which of the following tables is the relationship between the values of x and their corresponding y values nonlinear? All right, if it's linear, we should see a increase here 1 by 1 every time. We should see a constant increase here, and this one looks constant. It's going up by 3 every time. So I'm going to cross that off, because which one is not linear or nonlinear? This one going up by 1. This is going up by 4 every time. That's cool. So that's linear. This is going up by 5 every time. That's linear, so it must be D. But let's make sure. It's going up by 6. Then it's going up by 12, then 24. So that's not linear. 20. The dot plot above gives the ages and months, 25 babies. Which of the following is true about the mean and median of the data? Okay. Well, I don't want to calculate the mean. That's annoying, but we may have to. Okay, 1, 2, how many? 25 babies. So the mean is going to be the 13th value. Median. Median is when we line the data up from least to greatest and we find the middle value. So the 13th value, let's find it. Let's start at this end. 2, 3, 4, 5, 6, 7, 14. So the median is going to be the 13th value, counting from either the left or the right. So here's 7, here's 14. So guess what? The 13th value is in here. So my median is 14. Okay, let's erase this and write 14 for median. All right, to calculate the mean, I got to kind of add up all these values. So it's like 9 plus 10 plus 11, which is 30, plus 36, right? 3 times 12, plus 65, which is 5 times 13, plus 7, 98. 7 times 15 is 105, and that's it. So 30, 36, 66, 126, 131. 131 plus 203 is 334 divided by 25. 33 divided by 20. It's 13.36. All right, so the mean is smaller. That's it. Median. The mean is less than the median. Boom, done. Point C is the center of the circle shown above. What is the measure of angle ACB in radians? How do we convert to radians? Okay, here's the conversion. Radians is 180 degrees is equivalent to pi radians. So I put this nice little equivalency with degrees on the bottom, and we multiply across. These guys cross cancel to 2 and 1, and it's just pi over 2. Done. It's on my chart, the conversion to radians. So check that out on my Instagram. All right, just go to Instagram, search for Scalar Learning, and you can see that formula sheet. Next, the scatter plot above shows the number of visitors to a railroad museum in Pennsylvania each year from 1968 to 1980. Hold on. 1968 to 19. Oh, because it stops there. Got it. T is the number of years since 1968. Yeah. And the number of visitors, whatever. Which of the following could be equation for the line of best fit? Okay. I like that y-intercept of about 17. So, right, it's hitting the y-axis at about 17,000. So this is a y-intercept of 4,000. Nope. This is a y-intercept of 9,000. Even though they flip the order, that's the constant value. So 16,090 is what it must be. And it's either this slope or this slope. Let's see. Let's take 2 nice points. We're going from 0, 16,000, right? Approximately. These are just approximate values. 2, let's choose this point. 10 and 60, let's say 63,000. Okay? That's this point right there that I chose, making it up. You know, it's got to be on the line. And then we got to calculate the slope. So it's 63, so it's subtract the y's, 60. Is that 16,000, right? 16,000 minus 63,000 over 0 minus 10, which is negative 10. 16 minus 63. 16. 63 equals divided by negative 10, but I'll just say 10. Hey, what happened? Darn it. 16,000 minus 63. Come on. 63,000 equals divided by 10. There we go. Is 40, and it's positive because it should be divided by negative 10. So 4,700 is about the slope, not 9,000. And there we have it. A. That's a good line of best fit. Next, 23. Yeah, 34 minutes left, and we got about 16 problems. Actually, have 16 problems. The graph of y equals px is shown in the xy plane. Which of the following equations could define the function p? All right. How many zeros does it have? 1 and 2. But this looks like a third degree function. And the zeros should be, if I know I have a 0 at x minus 2, then I know, at negative 2, then I know this has to be one of the factors. If I have a function at 1, then I know that this is a factor. Why? Because these are points where the y is going to 0. So if the y is going to, y equals this. If the y is going to 0 at negative 2, this has to be there because then you plug in negative 2 and you get 0 and the whole thing zeroes out. Same with the 1. But we have something interesting happen here. When it kind of bounces off and doesn't go through it, then we're talking about multiplicity, which means we have a double root at 1. So I put an exponent up there and there's your answer. So it's x plus 2 times x minus 1 squared and done. The table above, it's a messed up table, but I think I get it. Hold on. F of x, let's draw a better one. negative 11, 10, negative 10, negative 8. Is this linear, I assume? Yeah, it's a linear function. 21, 18, 15, and 12. All right, I'm just going to straight up, they want the x-intercept, not the y-intercept. Basically what the x value is when f of x equals 0. Okay, but I'm just going to come up with a linear function. So let's first calculate the slope. Let's do let's subtract this way. So it's 18, no, let's subtract this way. So 21 minus 18, which is just 3, I'm just going to write that, over negative 11 minus negative 10, which is negative 1, right? Negative 11 minus negative 10, those can't turn into a positive. Negative 11 plus 10 is negative 1. So slope is negative 3. And we don't know the y-intercept, so we're going to solve for it. So I'll plug in, I don't know, 12 for y and negative 8 for x. So that's 12 equals 24 plus b. b equals negative 12. Okay, right? Subtract 24. I'm just going to go a little faster. So I think we're getting bad on time here. Negative 12. So here's my nice linear equation. And if I want to know the x-intercept, not the y, and yeah, we got to plug in 0 for y. So it's 0 equals negative 3x minus 12. Add 12 to both sides. 12 equals negative 3x. Divide by negative 3 by negative 3. X equals negative 4. Right? 12 divided by negative 3, negative 4. In the expression above, b and c are positive. If the expression is equivalent to x plus b, aka set it equal, right? Boom. What's the following value of c? All right, my instinct right away tells me that I want to solve for c, maybe. So I'm gonna multiply the denominator across, and because I can see something already. I can see a nice difference of squares. I'm gonna multiply this side by x minus b. X minus b. The denominator cancels out, and this becomes x squared minus c equals. Hold on. This becomes x squared minus b squared, believe it or not, okay? Because this is x squared, negative xb, positive xb, they cancel out, and then minus b squared. Now guess what? Now I see something special. I see that we can get rid of the x squared, and we see that negative c equals negative b squared, or c equals b squared. Boom. And b is an integer. Well, if b is an integer, b squared is, c has to be an integer squared of some sort. So the only thing that could work is a, because a is a square of 2. 6 is not a square of an integer. It's square, neither is 8, neither is 10. That's it. All right. Sn equals blah, blah, blah. The function above models the annual salary of an employee n years after starting a job, whatever, whatever. Okay. 4% each year. What is the value of A? Okay, look, this is also on my sheet. This is like you could say an exponential equation, kind of, but it's really more of a compound interest question, to be honest. And what goes in here in the compound interest is, if it's increasing, it's 1 plus the interest rate, but in decimal format. So 1 plus 0.04 to the n. That's your A value. All right. And if the other way to think about it to make sense is, in 1 year, we know we're going up 4%. So n would be 1. And so another way to solve it is you could be like, all right, well, if I do like, what's 1.04 times this guy? And you would get whatever you would get. Let's see. And it's 39,520, right? And if you didn't know this, we could have put an x in here and put a 1 here and solve for x. It's like we could have divided this value by 38,000, and you're going to come back to what you just did with 1.04, which is kind of funny. But anyways, that's a way to deduce it and figure it out if you don't remember the formula. It's a great workaround. Which of the following statements about the data represented in the box plot must be true? Okay, we know there's a median at 61. We don't know if there's a mean at 61. The range of the data is 50, yeah. Because the range is from the little tails at the end, and it goes from 37 to 87, so that's 50. Range is the biggest value minus the smallest value, that's it. This is not true, for sure. This could be true, but we don't know. There are more. Yeah. Then between 15. No, this one's not true either. This is the upper quartile and sorry, not the upper quartile and the lower quartile. It is. Those are the upper quartiles and the lower quartiles. So I think those are actually equal, even though the length is different. Those should be equal pockets. Okay. Numero 28. We've got these guys, value frequency distribution above. Where A is a positive integer. How much greater is the mean of the data set, mean of the set of data than the median? Hold on a second. This is the frequency. Got it. Okay, I think I get it. It's a ratio of 1, 2, 3, 2. Oh, okay. I get it. We can almost ignore the A's and just pretend it's like 1, 2, 3, 2, 1. Okay, and then here's the value. So the median is going to be 3. Because look, this is like a symmetric distribution. So if I pretend A, it doesn't matter what A is. A could be 10, 100, 1. So let's just make it 1. So there's 1 of these, 2 of these, 3 of these. So there's 1 of these, 2 of these, 3 of these, 2 of these, and 1 of these. The median is the middle value. It's right there. So the median is 3. Actually, they're both the same size. Because symmetric data, the mean and the median are equal, so it's 0. But let me show you how to calculate the mean. We just add up all these values in this case. So 1 plus 2 is 5, plus 9 is 14, 18, 22, 27. 27, and in this case I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So divided by 9 equals 3. So the mean and the median are both the same. Just remember, as a refresh, to calculate the mean, we add up all the values, divide by the number that there are there. Subtract those two and we get 0. Next. System of equations. A is constant. If the system of equations has no solution, what is the value of A? All right. If they have no solution, it means these lines are parallel. So actually, that's it. If they're parallel, they have the same slope. 2 is the slope of that one. Therefore, that one has to be a slope of 2. That's, if you know that definition of what it means to have no solutions, you're done. If it had infinite solutions, it'd be the same line. And if it had one solution, they just intersect at one point. A could be anything other than 2. Let me just make it so I don't cover it up. Next, we've got in the XY plane, a parabola has a vertex of 3, 1. All right. Okay. We got to get this into this format. So first of all, I'm going to say my formula is what in vertex form. It's y equals a times x minus h, where h is the x coordinate of the vertex, plus k, and k is the y value of the vertex. We don't have an a value. We don't have enough information to get an a value, but it doesn't matter. So I'm just going to try. The a value here is irrelevant. So if you can't figure that out, I mean, you could keep it in as a if you want, and you'll see it's irrelevant, but I'm just going to call it 1. I don't want to deal with it. And then my x value of the vertex is 3, so x minus 3 squared. My k value is 1. Boom. Let's FOIL this out. Actually, yeah. Let's FOIL this out. So this becomes, remember, this is x minus 3 times x minus 3. You have to FOIL, so it becomes x squared. Here, it's like this. I'm just trying to make sure I don't run out of time. That's why I'm going a little faster. But it's x squared minus 3x, which is minus 6x. And then, oops, that was to go there. And then negative 3 times negative 3 is plus 9, and then plus 1. And we add these two together to get 10. And guess what? That's the C term. The C term is this guy out here. And, oh, see that? I made a mistake. Hold on. What did I do? Oh. I got to back up. Thank God they didn't have 10 as the answer. I didn't read this. It intersects the x-axis, means it goes down. So A has to be negative. Ooh, they made that tricky. Let's rewind. So let's just make A negative 1. So let's make a negative in front of here. Okay? And they even gave us a second clue that it's got to be negative. So let's pretend it's negative 1. So then it becomes, could be the value. It doesn't say is the value. Yeah, because the A value will change it. All right, hold on a second. Here we go. I need to keep A in the mix here. I need to keep a in the mix. So we need, wait a minute. Oh, yeah, sorry. So if I say, hold on, x squared minus 6x plus 9 plus 1. And then the a value is like, let's say -1. It could be -1, and then this would distribute, and we'd have -9 plus 1 is -8. That could work. Actually, the positive ones can't work because this has to be negative. A has to be negative, so it could be -1, -2. If it were -2, this would be -1 times -2 times that, which is -18. That'd be -17. It has to be something like that. It can't be. It could be positive if it was like negative like 1/18 or something, and then it'd be that times that, which would be -0.5, and then it'd be positive half, but it can't be as high as 2 or 3 or 7. So that's what I'm going with, -8 for the C. All right, that was a pretty hard problem, but that's number 30. Those are usually hard. Car component not defective, defective, whatever. All right, the table above summarizes the results of testing 1,000 car components to determine which were defective. What of the defective components? Already, they're limiting our pool to only these guys. So don't look at the other numbers, they're irrelevant. Of the defective components, what fraction were component B? So B is 10 out of the total of only defective, so 25, 35, 40, 50, 100. Do the math again. We got to be really careful on the free response because there's no multiple choice to guide us. 10 out of 35, 45, 50, yeah, 10 out of 100. So we'll say 1/10. Done. Next. In the xy plane, what is the y coordinate of the point of intersection of these guys? All right, I want the point of intersection. I'm going to just set them equal to each other, right? 2x minus 3 equals x minus 1 squared. We're doing really good on time, so actually I don't have to worry. And then this, remember, this foils. So don't just think it's x squared minus 1 or x squared plus 1 or something. It foils. So it becomes x squared minus x, which is minus 2x. And then -1 times -1 is plus 1. All right. Now let's set everything. We got a quadratic. Let's set everything equal to 0. Subtract 2x, subtract 2x. And we get -3 equals x squared minus 4x plus 1. And then add 3, add 3. I'm going to use the space for this one. I have no choice, really. X squared minus 4x plus 4 equals 0. And then to find the solutions, we need to factor. Oh, this is nice. It's x minus 2 times x minus 2. Because it's negative 2x, it's what adds to -4, -2, and -2, and what multiplies to +4. Those work. So my solution for x, anyways, is -2. But they're not asking for x, they're asking for the y value. And then all I have to do is plug it into one. If you want to be smart, you plug it into both and make sure you get the same answer. But if I plug it in here, wait a minute. Oh, actually. Oh, hold on. Something's up. What am I talking about? It's not -2. I totally messed that up. It's +2. It's whatever makes this go to 0. So it's not -2, it's +2. Excuse me. Now I can plug that in to this equation. So I get 2 times 2 is 4, minus 3 is 1. So it's y equals 1. But we would just grid it in, of course, on the grid in as 1. And I'll plug it in here just to be safe. 2 minus 1 is 1. Squared is 1. All right, done. Next, in the triangle ABC above is a right triangle, and sine of B, of this angle right here, is 5. And sine is opposite over adjacent. So sine of B is 5 over 13. And if I call AC x, I know that, and sine of B is opposite over adjacent, which is x over 26. Cross multiply, 13x equals 130, divide by 13. X equals 10. So I already know this side here is 10. And now I can use Pythagorean's theorem to find side BC. Okay, I was just using a little trigonometry, SOHCAHTOA, which you definitely should know. And then, anyways, let's use Pythagorean's theorem. So 10 squared plus x, let's call it y. sorry, y squared equals 26 squared, okay? So it's 100, so 20, so then it's 100 plus y squared equals, what is 26 squared? Come on. 676. Then I'm going to subtract 100 from both sides, subtract 100 from both sides. I know this is crazy. Here, let me make some room. All right. And then I got y squared equals 576. That one I haven't memorized. I know that's 24, but I'm going to double check anyways. All right, square root 5, 6. Oh, wait, hold on. 24. Yeah. All right, so this one is 24. Let's circle that nice and big. Okay. We've got about 5 problems left and a good amount of time, so we're good. In the equation above, a is constant, a is greater than 0. If the equation has 2 integer solutions, what is a possible value of a? Okay. Wait a minute. What? Wait, hold on. Negative 7? I guess. This is kind of a weird question to me. I think all they're trying to say is if it has 2 integer solutions, all it means is like this can be factored. And if I were to, if a were 7, okay, if it's x squared, I'm trying to come up with a nice thing that's factorable. I think that's what they're asking. And if I were to break it, if I were to make a 7, it would be good because I could make it x minus 3, x minus 4. And I would have 2 integer solutions of 3 and 4. Yeah. So I think that's it. Because it would be, this would factor to be x squared minus 4x minus 3x minus, which is minus 7x plus 12. So there you go. And yeah, that's my answer, 7. I think you could have, it also could have been 8 as well. Then you factor it up, break it up into 6 and 2. And it could have been, and it could also be 13. Because, and you could also have minus 12 minus 1, and it could be 13. All right, we'll see if that one's right. Okay, next, the table above shows the coordinates of 3 points on a line in the xy plane. So it's a line, it's linear, where k and n are constants. If the slope of the line is 2, what is the value of k plus n? All right, watch this. Let's do a slope equation, right? So first, the slope is 2. So slope is, subtract down, okay? So 7 minus 11, the difference of the y's over 3 minus k, difference of the x's. And this all equals 2. That's our slope, right? So this would be negative 4 over 3 minus k equals 2. Multiply the denominator across. We get negative 4 equals 2 times 3 is 6, minus 2 times k is 2k. And then subtract 6 from both sides, subtract 6 from both sides. I got negative 2k equals negative 10. And then, of course, divide by negative 2, divide by negative 2. I've got k equals 5. All right, let's write that up here. Now let's make some more room. I'm going to kind of leave this set up here because we can reuse it. Okay, so we got k equals 5. Okay, makes sense. And then let's do a new equation. Let's use these values, 7 and these ones. So 7 minus n over 3 minus 12. And then it becomes 7 minus n over negative 9 equals 2. Multiply the denominator across. 7 minus n equals negative 18. Subtract 7. Negative n equals, combine those, right? Negative 18 and negative 7, negative 25. Divide both sides by negative 1. It's n equals positive 25. Right? And what is k plus n? 5 plus 25, it's 30. Okay, I'm feeling good about it, but I like that there's a lot of arithmetic, so there's a lot of room for mistakes. I'm going to go back and make sure these numbers make sense, okay? So am I always getting a slope of 2? So I'll do 25 minus 11 is 14 over 12 minus 5, which is 7. 14 over 7, it's 2. 11 minus 7 is 4. Over 5 minus 3 is 2. 4 over 2, that's also 2. And then 25 minus 7 is 18. Over 9, it's also 2. Okay, so I feel really good about that. 25, so the answer is 30. All right, 3 questions left. The acceleration due to gravity is whatever on Earth. On Earth is that much less than, so Earth is 1.3 less than 3 times whatever it is on Mercury. If the accelerator, so you see how I just set it up into an equation? That's because that's my instinct now. I just immediately go to set up an equation of some sort. Let's make that a lowercase e. And if the acceleration due to gravity on Earth is 9.8, now we just plug and chug. 9.8, what is the acceleration on Mercury? AKA solve for m. Really straightforward, right? Add 1.3. Add 1.3. Right, that's 11.1. Divide both sides by 3. Divided by 3. 3.7. Boom, boom, done. Kosumi, located in the city of Redfield, South Dakota, is trying to estimate the distances from Redfield to other cities in the state. And this is for both questions. On a map, he measured the lengths along major highways from Redfield to some other cities and listed these lengths in the table below. All right. The map that Kosumi used has a scale of 3/4 inches to 50 miles. Got it. I know this is crazy to set up a fraction on a fraction, but just bear with me because I think this is going to be the best way to play this one. Miles. All right. According to his measurements, how many miles is it from Redfield to Sturgis? Here's Redfield. Oh, sorry. And this is inches, so it's 6 inches, and we want to know the miles, aka x. All right. And I think I understood this question right. So now look, we got a nice proportion, and we can just cross multiply. All right, so 6 times 50 is 300 equals 3/4 x. To isolate x, we multiply both sides by 4/3. 4/3. Do this on a calculator if you're unsure, but 4/3 times 4/3 times 300 is 400. Okay. Last but not least, 10 minutes for the final problem. It's pretty awesome. All right. Kosumi is planning a trip from Redfield to Pierre and expects to average 60 miles per hour while driving. How long in minutes? Look, they underline it for you. How long, if you know, it'd be much harder if they didn't. I may have missed it. How long will it take for him to drive from Redfield, to Pierre? First of all, it's 2 1/4 inches, so we need to use that ratio to calculate the miles he's got to go. So again, it's 3/4 to, what is it, 50? Okay, equals, we know we're trying to get the miles again. And what is it? Where is he going? To Pierre, 2 1/4. 2.25. Let's not even have a fraction. All right, let's cross multiply. That's 112.5. I think 2.25. Oops. Yeah. 112.5 equals, let's make this into 0.75. So we keep it all uniform. Divide both sides by 0.75. $150. All right. Now we're going 60 miles per hour and we want to know the time. So it's 150 miles, whatever. And we can basically just divide it by 60. But if you want to, the way you want to think about it is it's like, I can go, in 1 hour, I can go 60 miles, okay? And then that cancels this out, right? If you want to think about it like this, it might be easier. And so now I'm already in a unit of time, but then I want to get to minutes. So then again, I put hours on the bottom so they cross cancel. And how many minutes equals an hour? It's 60. And then we got a nice little thing set up. So we got 50. Oh, and these, oh, these cancel out. So it's 150 minutes. Done. Let me just make sure that makes sense. Yeah, that's it. It's 150 minutes. All right, we're going to stop the clock, guys. And don't worry, if you have questions, just stay on with me. I'm going to take questions in a second. Let me just check the answers and make sure I didn't make any mistakes. All right. Okay, here we go. Here we go. Just put it on here. Desktop. We'll block out ignition point, leave master coach up there. Okay, now. Oh, all right, here we go. Let's see what it is. B, A, B, C, A. B, A, B, C, A. 6 is, hold on. A, C, D, A, D. Oh, shoot. I got one wrong. I got 6 wrong. Oh, no, it's B. It is B. I was looking at the wrong thing. Sorry. B, 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 A, C. B, 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 A, C. Okay, good. Because that'd be a little shocking if I got one that early wrong. Because, well, anyways. All right, next is 11. C, D, B, D, C. C, D, B, D, C. And then, what is that, 16? B, C, A, D. B, C, A, D. What is that? 20. All right, we've got B. Hold on. B, C, A, D, B. B, C, A, D, B. And then it's A, C, D, A, D, A. A, C, D. Shoot, I left one blank. Oh, no, I didn't. A, D, A. Right? A, D, A. A, D, A. All right, good. Now we got to the free response. Here we go. What? I got one wrong. Okay, so I wrote 1/10. It's 0.2. What did I do? Whoops. All right, let's see what I did wrong here. Damn it. 10. What fraction were component B? Defective. Oh, shoot. Oh, I misread the graph. Darn it. I didn't see that this said total. So you see that right there? I added that in. So I did 25 plus 10 plus 15. And I was like, oh, and then I added 50. So I was like, the total is 100. This is the total value. I missed that. I should have just circled these guys. This gave me the total. So it was just 10 over 50, which is 0.2 or 1/5. So there you go. Man, I just misread that graph. So there, the table. Happens. There you go. All right, next, number 32 is 1. 33 is 24. Good. And then 34, 7. Good. I think I mentioned, right, it could be 8 or 13. 16 is, or sorry, 35 is 30. 36 is 3.7. 400 and 150. Yep. All right, boom, boom. All right, let's open it up to questions. Let's see what we got. Yeah, all right, let me give my feedback too. I actually think it was overall a pretty, no, actually the calculator section was, I'd say like a medium level difficulty from what I've seen. But it's on the easier side. I mean, people were complaining about the curve. This could be why there was a curve. I know I heard that the test got leaked and there were different issues like that I'm sure affected it, but it was on the easier side. And usually that's how they set the curve, is based on the difficulty. And if you believe what the College Board says, they set it ahead of time, not after the fact. So I don't know, but it wasn't too bad. Even though I did make a mistake, hopefully that is a learning lesson to you. It was a really silly mistake. I just didn't read the table carefully enough. Okay, let's see if we got any questions. I'm taking it this Saturday. Yeah, you caught it. You caught it. Good catch, Mehranessa. Good catch. Yes. For people who are going to enter the test. Oh, you want like a SAT Math 2 test? I was thinking about doing that. Let me see. Let me think about it, because it's so different from the SAT. It's just not on point with the prep that I'm trying to do for everybody taking the actual SAT. But it is what it is. All right, so I don't see a lot of questions. I'm going to end it here. Thank you guys so much for joining. These are really fun for me, and I hope they're helping everybody and getting you guys in shape and ready to go when it comes to test day. And yeah, I agree with you. I think it was an easier test. I think that's why the curve was so lenient. Yeah, I don't know. That's my thought. But anyways, we're going to get you ready for the June test, guys. Thank you so much for joining. If you like this video, if you guys are still watching, please click the like button. If you haven't clicked it yet, I really appreciate it. Helps the videos out, helps them get more traction and get more visibility so more people can find these resources and get help from them. And I'm sure it's not for everybody, but I know a lot of people have been telling me that they've been really valuable in their prep process. So please do that for me if you can, and leave any questions in the comments if you have them. I'd love to hear from you. Subscribe if you want to see more from the channel. Don't subscribe if you don't, but hopefully you do. Thank you guys so much for joining. Have an awesome rest of your weekend. Have a great long weekend. I'll be streaming again tomorrow, doing more SAT math from a different test. Thank you guys so much, and I'll see you all next time. Take it.